Okay, ELE 112, Section 8-4, Superposition, Video 3 for you guys. Here's exactly the same circuit you've done once or twice now. Actually, once, I think. Look at the two power supplies, though. They're facing exactly the same way, up. They're facing exactly the same way, in the up direction. I've gone ahead and drawn the direction of current flow. We said what? Always choose out of the positive supply. So I've got this red, line coming out of this battery going this way and going this way back to the battery. Then I've got the black line, the same battery. Well, it's a different value. It's 9 volts. But what I do have is a flow that takes us that way and that way. Now, if I get rid of all the lines that I've thrown on there so that you can see my black and red stuff, you'll notice that if we're analyzing this for anything meaningful, that this resistor in the middle, which is known as IR3, has exactly the same direction of current flow. So when we write its equation, we put a plus in the middle because those are definitely being added. They are definitely going in the same direction. Now, one supply is 12 volts, one is 9 volts. I would assume the 12 volts wins, but what do? We always assume V1 is larger than V2. And because of this, we always assume that the direction that V1 is flowing is right until proven wrong at the end of the problem. So we take a look at this resistor right here, IR2, and we notice that the currents go in the opposite direction, red to the right, black to the left. So when we build the equation, which this is just a guess, we put a negative sign in there. Simple enough. Again, V1 falls in this column. V2 is part of the second column. The reason V1 is first is because we assume V1 is the biggest one all the time. Okay? And if we look again at resistor R1, we find out that those two currents are flowing in opposite directions yet again, right there. So because of that, we've got to put a subtraction sign in between the calculation that we make of right here for I1. So that's what we're after. We're going to start with circuit 1. Circuit 1 is going to allow us to compute everything that we possibly want related to these three quantities. So here's the circuit. You take a look at it, and you see that the first thing we do is remove the power supply with a short, which is probably located right here, I'll assume. And I took this 15 ohm resistor and I folded it over because those two dogs are in parallel. So we want to be able to see that very easily if possible. And that's the best way to do that. So that being said, we've got a series parallel circuit, and we compress this section down to one resistor here, and we call it 6 ohms. 10 ohms and 15 ohms produces 6 ohms. That sounds about right to me. Definitely sounds about right to me. So we start looking at this circuit right here, and what we come up with is the fact that it's a series circuit. So we solve for the total. We have a lot of ways we can go. We can solve for the voltage of V1 using voltage divider. 12 times 30 divided by RT, which is 36 ohms right here. How's that suit you? We're attacking this one from a different angle using a different set of tools. Now that will set us up for finding the current through that channel, which happens to be that value. This is that value. Then we go back and we take a look at what we've got left here with this parallel chamber that we have. I'll go ahead and put that back right there. We've got this parallel chamber right here. And you know, if I could find the voltage of that using voltage divider, which is 2 volts, then I can do the same thing I did with R1. I've got 2 volts sitting across those two resistors, and there are 2 of them. One is 10 ohms and one is 15 ohms. That allows me to be really fancy here and go get some currents. Now that happens to be that current, and this happens to be that current, and we've just finished half this problem, and we didn't really work too hard. We really did not work too hard. Look at that. That is so sweet to be able to do that. Take a look at it because we're going to move to a new slide. Here is the second page of this circuit, and everything we need is located on it. If you give me a chance here to get a nice marker in my hand, there we go. We see that this circuit looks a lot like the first circuit, except the battery's on the right side. So we short out the power supply somewhere up in this region with a wire, and this becomes a simple series circuit. And I hate to tell you this, but we used voltage divider to go get VR2 of 6 volts. We didn't have to. We could have found IT and we could have gone that route. I just wanted to do this a different way. That gives us I2. Well, why do we need I2? We need I2 because we're trying to find 3 things in this half of the circuit. This is required for that location. So, moving on, because we know that the first side has, there's 6 volts here. Because we know that, we know there's 3 volts right here. Did we really have to calculate it? No, we could have used Kirchhoff's voltage law. I'm going to say it again. That's what makes this so challenging, so fun, so exciting, is that you can use multiple techniques to solve the same things many different ways. So there's the first thing we solved. Then we went and used Ohm's law to get us the current through I1 and I3. And those need to be placed right here in this location. Right here and right there. And when you do the calculations of all these numbers, you find out that in the overall scheme of things, only one of these circuit loops was assumed to be incorrectly assumed. And that was the third one for the current through R2, which is right here in this location. The current is actually not going this way. The current is actually going that way. So if we were looking at this whole circuit with an ohm meter and we wanted to hook up to it to make some measurements, I would hook up to it here like this. And if this was the red lead and this was the black lead, I would get the incorrect orientation on my voltmeter. That's the only repercussion. The other two locations were done just fine. Over here, IR1 was bigger than IR2. The only reason that this one has a larger current on it is it happens to be right next to the battery out here, and it does get what would essentially be called VIT from the 9-volt battery. So, hope you like that example.